Hello everyone, this is your teacher Justina, and for our video today, I will be discussing the solution of the system of linear equation into variables. But before that, let us try see which of the following set is a system of linear equation into variables. Let us have number one. It's a system because the two variables x and y are present and there is the presence of the equal sign. Well, example number two, it is not a system because the first is just an expression, it's not an equation. While number three, it's not a system because the first is composed of three variables while the other one is composed only of two variables. And then the last example is a system because the two variables x and y are present and there is the presence of the equal sign. Okay, let us define a system of linear equation. When we say system of linear equations, it consists of two or more linear equations made up of two or more variables. Let us have example number one. This is a linear equation or system of linear equation in two variables. The x and y are both present in the first and second equation. While number two, it is a system in three variables, while the third one is a system in three variables. And so far, when we say system, consists of two or more linear equations. So that's example number three. This is composed of three equations that are linear and made up of three variables. Okay, so let us familiarize the different types of systems. The first one is the dependent system. This system has infinite solution. As you have seen, the two graphs are coinciding. So if the two graphs are coinciding, we refer to the same line. So if they are coinciding, then take note it has infinite solutions. So the graph coincides or refer to the same line. Let's proceed to the second system. This is what we call the independent system. So this system has exactly one solution. So as you have seen that the two graphs are intersecting, and this point of intersection is said to be the solution to the system. So if we are to refer it to the graph, then the graphs of this system, which is independent, intersect at exactly one point. So if they intersect at exactly one point, then it has also one solution. And the third one is the inconsistent system. So the system inconsistent has no solution because they never meet each other, they never intersect. So if this is the case, then the two graphs are parallel. So if they are parallel, then there's no solution. So let's proceed to the sketching of the following system. So let us have the first equation. So the first equation is being given 2x plus 4y is equal to 8, which is transformed into y equals mx plus b. And then for that, we know that the positive 2 is our y-intercept, and the negative 1/2 is our slope, which is going down 1, and then going to the right because it's a positive 2. So therefore, that is the graph of the first equation. And then the second equation is refers to x minus y is equal to 6. And the slope-intercept form, which is y equals mx plus b. So the b there is negative 6. So as you have seen, the graph uh, cross the y-axis at negative 6. And since this is understood that our slope is 1 over 1, that means we go up 1 unit and we go to the right 1 unit. And that is the second point. So to connect the points, then that's it. So as you have seen, the graph or the two graphs able to intersect at this particular point. So how do we describe the system? So this is independent system. So this is independent system because the graph intersect at each other. And then let's proceed to the Next, the 2x plus 2y is equal to 2. And then we'll be plotting this according to x and y intercept. So getting the y-intercept, then uh, we have to get the value of y, but since we'll be getting the y-intercept, we will be setting x to 0. So 2y is equal to 2, thus over 2, then our y-intercept is 1. So as you have seen, our graph uh, is being intersected at the point 0, 1. Let's proceed to the x-intercept. So we have 2x plus 2 times 0 because we are getting the x-intercept, thus the y should be 0. So 2x is equal to 2 and then over 2, then x is equal to 1. And what is this? This is our x-intercept, and that's it, 0, 1. So the graph will be that one. And then let's proceed to the next equation. So the x plus y is equal to 1. So getting the x-intercept, the 0, there is the y, and then x is equal to 1. So where is, okay, that's it. I know, the x is equal to 1, so it's in here. While the y-intercept we have 0 plus y is equal to 1, thus our y-intercept is 1. And then we reference to the same point, the graph. So that's it. So as you have seen, the two graphs coincide. So it has made up of infinite solution. So how will you describe the system? This is what we called uh, dependent system. So this is a dependent type of system. So when we say dependent, the two graphs are coinciding. Let's proceed to the next. We'll be plotting this first equation, so positive 1. So that will be going to this starting point. This is 0, 1, our y-intercept. And 2, third is our slope. So that means we go up twice and we go to the right 3 times or 3 units. I'm sorry. Thus, that is the graph of the first equation. And then while the second, negative 4 is our y-intercept, so we have to plot the first point in there. And then followed by the slope is 2 over 3. So going to the going up is how many units? So 1, 2, and then 1, 2, 3. There is the second point. So the graph is this. So how will you describe the two graphs? So they are parallel to each other. They never meet. So the kind of system is said to be inconsistent. So when we say inconsistent, when can we obtain an inconsistent? If the two graphs are parallel to each other. But remember, if we have lines that are parallel, as you have seen, they have the same slope. So remember, parallel lines, they have the same slope, but different y-intercept. So remember that. So parallel lines have the same slope but different y-intercept. Okay, let us now find the solution to a system of linear equation into variables. But remember, there are different methods in finding the solution to a system. But before that, we have to define solution to a system. So when we say solution to a system, it refers to, so again, the solution to a system uh, is any ordered pair. So when we see ordered pair, it is made up of x and y that satisfies each equation independently. Suppose you are given, the instruction there is find the solution of the system by graphical method. So let us have first uh, finding the solution to a system by graphical. So by this time, we can determine the solution through graphing. So let us have number 1. So 2x minus 3y is equal to negative 6 will be plotted in this manner. So getting the x-intercept, so that will be 2x minus 3 times 0 is equal to negative 6. So 2x is equal to negative 6 all over 2. So our x-intercept is negative 3 and in there. And then getting the y-intercept, thus 2 times 0 minus 3y is equal to negative 6. Thus negative 3y is equal to negative 6. And then what will be our y-intercept this time? It's positive 2. So where is the positive 2? So it's there. So connecting the points, we have the graph of the first equation. And then the second one, through the x and y intercept, we have plotted x plus y is equal to 7. So at this time, as you have seen, the two graphs are intersecting at this particular point. And then for that, let us now try see what is this. So if this point is the intersection of the two graphs, then let us try see if this is really the solution. So when we say solution, it is an ordered pair. So if it is an ordered pair, is this really satisfying? Do we obtain an equal value from the left and right term of our equation? So we have if x will be 3 and y is equal to 4, so far substitute it to the original equation, thus it's equal. And then the next one is x plus y is equal to 7. Then the x is 3, the y is 4, and then 7 is equal to 7. So that means that graphically we're able to get the solution. So the 3, 4 is said to be the solution of the system. Let's proceed to the next example. You are given x plus y is equal to 3, and then transforming it into a slope-intercept form. Thus, positive 3 is our y-intercept, and then so our y-intercept is at 0, 3, and then since our slope is negative 1, thus we go down once and go to the right once, and then that's the graph. And then the next equation is y equals 2x minus 1. And so for the negative 1 is being plotted already. So y is equal to negative 1. And since it's 2, going up 2 and then going to the right once, so therefore that's it. So as you have seen, we have approximately having the point of intersection in which this is 1.3 approximately and 1.7 for the y. So how do we know if 1.3 comma 1.7 is really the solution to the system? Thus, we will be checking. So the x plus y is equal to 3, in which our x is 1.3, our y is 1.7. So far, 3 is equal to 3. And then while the next one there is 2x minus y is equal to 1. So 2 times 1.3 minus 1.7. Remember that we have this one. We have substituted the x and the y. Thus, 1.6 minus 1.7 is equal to approximately 1 is equal to 1. Okay, so far we are done with the first method, finding the solution to a system of linear equation into variables. So by graphical method. Guys, I want you to follow me on my YouTube channel because there will be a part 2 of this video. I hope you learned something, guys, from my video today. Goodbye and thank you.